Now under apoptosis, the next topic that we need to know, which is again a favorite with the examiners, happens to be the diagnosis of apoptosis. Now students, if you have properly understood whatever we have read under apoptosis up till now, then this topic is nothing but a summarized version of what we've done up till now. So we will start with diagnosis of apoptosis. How can we diagnose apoptosis? The first method, which all of us know, the light microscopy. Now I want you to revise. Light microscopically, what was the size of an apoptotic body? Correct, there was cell shrinkage. Second, what was the nuclear characteristic? It was nuclear chromatin condensation. And please recall, nuclear chromatin condensation was the hallmark of apoptosis. Now this is the first way of diagnosing, that we see the slide under the microscope and we get to know that whether apoptosis is present or not. The second mechanism, the second method of diagnosis. Now we know that there was one molecule that was coming out from the mitochondria. Yes, that molecule was cytochrome C. So we can test levels of cytochrome C. We can test levels of cytochrome C. That is the second method. The third method, again this is something you know. What is the marker of apoptosis? Correct, we just discussed this. The marker is annexin 5. Now if the question is slightly twisted and they ask you the molecular marker, so we just discussed it was CD95. So students, these are the diagnostic methods that you already have read up till now. What are we going to add in these methods is a very important one, something known as gel electrophoresis. Gel electrophoresis. Now, why is this so important? This is one of those images in pathology which is mandatory, that you should know this before you sit in any board exam. Most important and most favorite image with the examiners. Gel electrophoresis pattern of apoptosis. Now, how will we understand this? Just now we studied that in apoptosis there is activation of an enzyme known as endonuclease. We just discussed this, endonuclease. Endonuclease has a very important property, that it causes internucleosomal cleavage. Internucleosomal cleavage. And what do you mean by internucleosomal cleavage? So let's take the example. For example, if this is one DNA, this is the 5' end and this is the 3' end. Now what this endonuclease is going to do? This endonuclease is going to go and nuclease, it will break the nucleic acid material. So it is going to break the DNA like this. But what is important is that it follows a pattern. It will break the DNA in multiples of 180 to 200 base pairs. So at every multiple of say 200 base pairs, it is going to break the DNA. That is how an endonuclease is different from the rest of the nucleases. Now when it does this on electrophoresis gives a very characteristic pattern that students, all of us have read, is known as the step ladder pattern. Step ladder pattern. So there are 2 or 3 important questions that come up over here. The enzyme activated is endonuclease. Endonuclease causes internucleosomal cleavage. It is going to break the nucleus at base pairs of multiples of 180 to 200, and this will result in a step ladder pattern on electrophoresis. Now this, rather than a theoretical question, is more favorite as a image based question. So this is the image that we need to refer to, and hopefully with this diagrammatic representation of a ladder you will be able to remember. So over here you can see 3 images, A, B and C. What you see over here, this entire thing is a gel electrophoretic plate, and over here the DNA of a person is placed. At one end the DNA of the person is placed. Now if the DNA of the person is intact, there is no apoptosis, there is no necrosis, there is no cell death, intact normal DNA, it will only migrate up till here because the DNA is compact, it is not broken into pieces. On the other hand, if there is a person who has apoptosis going on in the body, if there is a cell which is undergoing apoptosis, in that person, we just discussed, endonuclease will break the DNA in multiples of 200 base pairs. So these are the bands that we are going to get. These are bands of DNA. Such bands resemble the bands of a ladder, and this particular appearance is what we just studied as the step ladder pattern. So students, most important image in general pathology, step ladder pattern, apoptosis on which technique? Gel electrophoresis. Now coming to the third pattern. The third pattern that you see over here. Over here, if I just draw this out like this appears like a smear, right? So over here, one thing you need to know, the DNA is broken. It is traveling, the broken bits are traveling on the electrophoretic plate till a very long distance. But are they forming the same bands that we saw in gel electrophoresis of apoptosis? No. Over here, there is one continuous pattern that you see, and this pattern is known as the smearing pattern. How will you understand this? Just like we make a peripheral smear, a tongue-shaped peripheral smear on the slide. Similarly, this also resembles a smear. I am calling it a smearing pattern. Now remember that a smearing pattern is seen in necrosis. So these happen to be the next set of differences between apoptosis and necrosis. Apoptosis will show step ladder pattern. Necrosis will show smearing pattern. Coming back to the theoretical aspect. This was the fourth diagnostic method for apoptosis. The fifth diagnostic method that we have also is on the same particular concept. The fifth is known as the tunnel staining. The fifth is known as the tunnel staining. Now what is tunnel staining? So focus on the word tunnel. T stands for TDT. U stands for UTP. This is nick, end and labeling. So that is the entire full form, and you just need to focus on the terms now. TDT is an enzyme that is going to attach UTP at the ends of the DNA. Which ends? Now, if you recall, we just discussed that, for example, if this is the DNA with a 5' and a 3' end, in a cell undergoing apoptosis, the material has been broken. I hope you can recall at multiples of 200 base pairs. So now instead of this one DNA, we have multiple pieces that we have obtained. Each of these will have a 5' and a 3' end. Each of these will have it. What TDT is doing, it is going to bind UTP at the 3' end. So at every 3' end, it is going to bind UTP. Now friends, if the DNA was intact, UTP would have just gone and attached to one 3' end. Now we have so many pieces, so UTP attachment is to more number of pieces. Finally, if more the UTP is attached, the end product or the color or the stain color in the end, at the end, what do you expect the color to be? More UTP attached, there is going to be more intensity of the stain. So this is very important. Nick and labeling is nothing but a staining procedure. If you know that in this staining procedure, UTP जितना add होगा, उतना ज़्यादा stain हमें end में मिलेगा. End में intensity will depend on the amount of UTP that was added. Obviously, in a broken DNA with so many 3' ends, more UTP added, which means more intensity of the staining. So this is a very important feature that is seen only in apoptosis. This is not seen in other forms of cell death. So if you have to summarize, we first had light microscopy. Second, we had cytochrome C. Third, we had markers like annexin 5. molecular marker like CD95. Fourth method was gel electrophoresis showing step ladder pattern. And fifth was tunnel staining, which was positive in apoptosis. Now this is one of the most important crux of this particular topic that you need to memorize. Now friends, towards the end of apoptosis, if we just want to discuss the two forms of cell death that we just did, necrosis and apoptosis, a quick revision would be: necrosis, is it physiological or pathological? You are right, necrosis is always pathological. Apoptosis can be both physiological and pathological. Necrosis usually it tends to be pathological, as we just said, but in this, what will you see? Will you see inflammation? Yes, inflammation is present. In apoptosis, inflammation is absent. Which of these uses caspases? It is apoptosis. Which of these is going to show cell shrinkage? Again, you are correct. It is apoptosis. Gel electrophoresis of necrosis will show which pattern? That is smearing. Of apoptosis will show step ladder pattern. Tunnel staining will be positive in which of the forms of cell death? That is apoptosis. So this is a brief summary of the differences between necrosis and apoptosis that we need to keep in mind. The last question with which we can end the discussion of apoptosis is a recent question that has come up in the exams. And the question say that what is the effect of steroids? What is the effect of steroids on apoptosis? So now we know steroids like glucocorticoids, sex steroids, how are they affecting apoptosis? So if I divide or consider just two of these, that is glucocorticoids and sex steroids. So remember that glucocorticoids will always stimulate apoptosis. Glucocorticoids are going to stimulate apoptosis, or I can say they are pro-apoptotic. Indirectly we can say they are pro-apoptotic. Sex steroids on the other hand will inhibit apoptosis. They will inhibit apoptosis. So I can say that indirectly these are anti-apoptotic. These are anti-apoptotic. So remember friends, this is one of the recent questions that has come up, the effect of steroids on the apoptosis. So glucocorticoids pro-apoptotic, sex steroids are anti-apoptotic.